All right, I'm going to jump around and do a couple of other examples. I'm going to start with number 7. Y is less than or equal to 3. Guys, remember that when you have just y is a number, then you have no slope, which means that this is a horizontal line. So 0, 2, 4. So 3 is going to be right here. No matter what x value I have, the y value is always 3, so that creates a horizontal line. Less than or equal to means that I can draw a solid line. And then because it's an inequality, I need to shade one side of the line or the other. If I pick a point 0, 0, well, there's no place to put in an x value, so I only put in the y value. 0 is, in fact, less than or equal to 3. So when I choose the point 0, 0, it makes the statement true, and I'm going to shade this way. Okay? Okay, I just cleared out the previous equation, but I need to go over here and change this because this time, oh, dark gray, sure, whatever. I didn't mean to do that. But anyway, I need to change this to a less than or equal to situation. There it is. Okay. So there we go. And then we're going to go over here, and all we have to type in is 3. My window settings should be okay for this particular situation, so I'm just going to hit graph. And there you go. It's the same graph as what we just did. Okay. All right, the next one we're going to look at is number 12. I'm going to sort of do my own thing instead of following these directions exactly. Basically, we're going to solve it for y, figure it out by hand, and then check it on the calculator. Okay. So the first thing I'm going to do is I'm going to have to move that 15x by subtraction. And I'm going to divide everything by 20. And I get y is less than 15 over 20 reduces to 3/4. So negative 3 over 4x. And then 14 divided by 2 is 7. All right. With a grid paper, I'm going to start at a y-intercept of 7, and I'm going to go down 3 and over 4. Down 3 over 4, down 3 over 4. There's my line. Let me trace that real quickly. All right, I hope you're seeing immediately that I've already made a mistake and I'm going to have to redo this because I was just kind of off in la la land. This line should not be solid because this only says less than, not less than or equal to. So let me redo this. Okay, so there's my line. It's a dashed line again because it just says less than. Then I've got to figure out which way to shade it. And I like to use the test point 0, 0 because it's easy. So if I put a 0 in here and a 0 in here, this whole side becomes 0. And is 0 less than 140? And it is. So that's the side that makes the equation true. So any point in the shaded area would make the statement true. 0, 0 makes it true. This point right here, 4, 3 would make it true. Any of those points would make it true. Okay, over here, let's clear this. Again, this is a less than situation, but again, your computer, your graphing calculator is not going to really tell you, hey, the line should be dashed or solid. So you kind of have to figure that out yourself. Again, I'm going to put the equation negative, I'm going to put the fraction in parentheses, negative 3/4 x plus 7. And again, I should be okay with my window settings the way they are. So I'm going to hit graph, and there we go. Okay, the next thing I'm going to do is number 13. And it's just that they've gotten a little bit more complicated because I have a couple of different places where I have y appear and I have a couple of different places where I have x appear. You just gather like terms and then you do the problem just like you would do any other problem, solve for y, okay? Okay, so I colored or shaded these to red because they're like terms. This one's got a positive, even though I didn't write a plus sign in front of it. So that's a positive 4y and a negative y. And then here is a positive 3x. On the other side of the inequality sign is a negative 6x. And then I've got a number with no variable, whatever. So once I do like terms, 4y minus y is going to be 3y plus 3x is greater than negative 6x plus 12. Then I'm going to say minus 3x. Minus 3x. I get 3y is greater than negative 9x plus 12. And then I need to divide everything by 3. Sorry, I'm going to run out of space here. Divide all of this by 3. I'm going to come over here. That's going to be y is greater than negative 9x over 3 is negative 3x. And then 12 divided by 3 is a positive 4. So here's my equation. And I'm going to go up here. And I'm going to graph it. I'm going to start at 4, and I'm going to go down 3 units and over 1. Down 3 units and over 1. When I draw my line, I better not mess up this time because it's on the actual textbook page. I'm going to leave it a dashed line because it doesn't say y is greater than or equal to. It just says y is greater than. Okay, so there's my line. And again, I like picking 0, 0 because it's easy. When I put a 0 in this term, and this term, and this term, all of this becomes 0. That becomes 0 because my x and my y are both 0. So all of this over here is 0, and I have a positive 12 over here. Is 0 greater than 12? No. So this point on this side of the line makes the statement false. So I'm going to shade on the other side over here. So any of these points on the shaded side will make that equation true. Will points on the dashed line make the equation true? No, because remember, the dashed line indicates that points on the line do not satisfy the equation. If it was a solid line, then yes, it does. Okay. One more time, let's go practice doing this on the graphing calculator. So I'm going to clear all that. I need a greater than sign this time. So I'm going to come over here and fix that. Hop down here, hop over there for greater than, enter. And then I'm going to come over here. And now I'm going to enter negative 3x plus 4. My Windows settings should still be okay. And so I'm going to hit graph. And there it is.